Hello dear students, in this video we will explain a new physics chapter which is resistors. Let's list the objectives together. Define resistors, indicate the characteristics of the two terminals of a resistor, infer the characteristics voltage current of a resistor, state Ohm's law. Let's begin with the first objective. What is a resistor? We will discover this through this activity. Here we have two circuits. In circuit 1, there is a dry cell connected to a lamp with no resistor, while in circuit 2, we have the same lamp connected to the same dry cell, but a resistor is installed in series between these two. Compare the glowing of the two lamps. True, the lamp in the presence of a resistor glows weakly. This means what? That the electric current passing is less. Thus, the resistor resists the passage of the electric current. That's why it's named resistor. So a resistor is an electric component that decreases the flow of electric current in the circuit and transforms the electric energy into heat. That's why resistors are used to protect fragile devices in circuits. For example, if too much current flows in a LED lamp, it will be destroyed. So resistors are used to protect such devices, as you can see in this figure. Now, let's move to the second point, which is the terminals of a resistor. This is a resistor with its two terminals, here named A and B. The symbol of a resistor could be one of these two, this one or this one. But the question is, are these two terminals the same or they are different? We will discuss this in the following activity. In this activity, we will measure the current carried by a resistor having the two terminals A and B, connected to a 6-volt dry cell by using an ammeter. The value read by the ammeter is 127 milliamperes. Now, we will reverse the terminals of the resistor and measure the current carried by this resistor again. As you can see, the value is approximately the same. Same sign, same value are obtained in both cases. Thus, the two terminals of the resistor are identical. Now we will move to talk about Ohm's law and the characteristic voltage current of a resistor. But before, let us be introduced to the German physicist George Simon. George Simon Ohm was a German physicist who discovered in 1827 some laws relating the current flow in a wire to the voltage and resistance. Ohm found that electricity in a wire acts like water in a pipe. Let's see how. To study the characteristic voltage current of a resistor, we will build the following circuit. In this circuit, we will have a variable DC source. Variable means its voltage can be manipulated. This arrow indicates that it is variable. And of course, in this circuit, we have a resistor, a voltmeter to measure the voltage, and an ammeter to measure the current in order to study the relationship between these two. The values of voltage and current obtained after performing this activity are tabulated below. When the value of voltage is 0, the current is 0. When it increases to become 0.5 volts, the current also increases to become 10 milliamperes. As the voltage increases, as you can see in the table, to reach the maximum value here, which is 4 volts, the current also increases to reach the maximum value, which is 78 milliamperes. Now let's calculate the ratio U over I. When calculating this ratio, we can observe that the value is constant. This ratio is called the resistance of the resistor, and it is represented by the symbol R and expressed by the SI unit ohm. Now we will use the values obtained in the table to draw a curve. So draw a curve giving U as a function of I. This curve is called the characteristic voltage current of a resistor. Observe this curve. As you can see, the curve is a straight line passing through the origin. Note that each resistor has a specific resistance. Then, from this activity we can deduce Ohm's law. We calculated in this activity the ratio U over I, which is equal to R. Then R is equal to the voltage divided by the current. Therefore, U will be equal to R times I, where U is expressed in volts, I is expressed in ampere, and R is expressed in ohms. Then Ohm's law states that the voltage U across a resistor is the product of its resistance R by the current I it carries. Now let's watch this simulation that shows the relationship between the three factors. As we increase the voltage, the current increases. Now the voltage is equal to 3 volts, the current is equal to 6.1 milliamperes. As we increase the voltage more, the current carried by the resistor increases more. Here we are using the same resistor. But what if we change the resistance? As R increases, current decreases. Thus, resistance and current are inversely proportional, while voltage and current are directly proportional.